Indulge me for a moment. You need not write anything down for a moment. But I need to make sure that everybody remembers something from the 10th grade. So here's what I'm going to do. I'm going to write an equation on the board here. You don't need to write it down, just look. Well, I won't write it down yet. There we go. Do you, as grade 11 pre-calculus students, remember how to take that equation written in standard form? That happens. And put that equation onto a graph. There are numerous methods of doing this. I do not require you to know all of them, but I do require you to be able to take that equation and put it on a graph. Who remembers at least one way to do that? Remember, you don't have to write it down, just tell me one way. Pardon me? Yes, you could put it into slope-intercept form, which is y equals frozen computer plus piece of crap equals Myers sledgehammering the computer by the end of the year. Y equals mx plus b. That would be one option. Is there another option? The other option? Yes, Julia. Yeah. Yes. So what Julia is saying is you could isolate either value, solve for it, pick a value, sub it in, and solve for it. What she is basically doing is describing, making the good old-fashioned, you might call it a T-chart. I, of course, call it a table of values. You could do that. Choose a value. X is 0. You would put 0 there and then figure out what your Y is. Right? And then you do that 3 times, then you make a line. All right, what else? Is there another thing you could do? The only other thing that I showed you if you were in my grade 8 class or grade 10 class is you could do your X intercepts and your Y intercepts. Put them on the graph and connect the line. Everybody remembers these, yes? All right. And all of these require you to do some algebra up here, don't they? You're either putting it into this form, which then you know the y-intercept and the slope, or you're choosing values and substituting in and solving, or this is essentially this, but you've got set points. Everybody remembers this from the 10th grade, yes? Or, of course, if you're from another country, you remember this from the 4th grade. Everybody's good? And when I graph this, what shape am I going to get? Or I shouldn't say shape, that makes it seem not very fair. What will the graph look like? Going once. No. It will make a line because that is a linear equation. Yes? Because for every x, I will get a different y value. Yes? Everyone is good with that? We all remember that? All right. A linear equation, any equation that looks like this. Does it have to be x's and y's? No. Could I have distance and time? Yes. Could I have height and time? Could I have pay and time? All right. So as long as I have 2 variables and the equation looks like this, I can graph a line. Yes? All right. What are those two variables called? Who remembers that? Don't say x and y, because I said they could be any variable. They have a name. Say that louder, Sophie. Independent and dependent. Where is the independent variable? Graphed. On the x or the y axis? On the x-axis. The dependent variable is graphed on the y-axis. What do we call all the values that are on the x part of the line? Does anybody remember that? Starts with a D. Ends with an N. Has omé in the middle of it. Domain. Excellent. What do we call all the values that are on the y? Range. Excellent. Some of you had a very good Math 10 teacher. Well, that is not my problem. I know that, Yoon. It's a joke because I taught a lot of them grade 10 math. That's why I do that joke. Because I was the majority of their grade 10 math teacher. Stop it, Yoon. I don't need that right now. I'm not actually angry at Yoon, everyone. It was something he did to Megan earlier on, so I'm doing that right now. Because Megan offered him a cookie and he got mad about it. Or something. Something went on over there, and I don't know exactly what happened. All right. Everybody remembers this? All the straight line stuff? Okay. Now, let us move on, cabbages, to the new stuff. All right? This is page 71 in your book. You should open up to it. Grade 10, you graphed straight lines all over the place. Yes? Positive slopes, negative slopes, zero slopes, undefined slopes, point slope form, general form, slope intercept form, T-charts, tables of values, independent variable, dependent variable, distance versus time, all kinds of stuff, yeah? In grade 11, anticlimactic because the computer froze. In grade 1, in grade 11, the graphs are going to look like this. Ooh. They're going to be curvy. Okay? But you should notice that they're on the same thing, yes? So are they made of x's and y's? So do the same basic concepts that apply to lines apply to the curves? Yes. Everybody good? All right, let us begin. The very first thing, the very first objective today is to discuss quadratic functions. That is one of my favorite fonts. It is Dr. Seuss font. And luckily enough, I am wearing my Dr. Seuss tie today. That was not planned. It was just good luck. I think I should buy a lottery ticket today. Of course, if I win the lottery, I will not be here Monday. I am not one of those losers that wins $50 million and says, it's not going to change me. I'm going back to work Monday. Okay? No. Huh? If I won $50 million, do you think I would be here? Okay. Yes, I love you guys very much. But do you think that if they did not pay me, that I would come here anyway?
Yeah, you love math and you love us.
If I won $50 million, I would not be here. Now, to be fair, I would probably spend 1 or 2 years of doing absolutely everything I wanted, which would, of course, be surfing everywhere. I would go up to Alaska, I would get a special wetsuit, I would wait till a glacier fell into the water, and I would surf that wave. Then I would go down to Texas, where the big freighters go by and make giant waves, and I'd surf that wave. Then I'd go down to Antarctica when an iceberg falls off because global warming isn't real, and nothing's happening to the icebergs, and I would surf that wave with penguins. Then I would go right? I would do that for 2 years. Then I would honestly be bored. Actually, no, if I had $50 million, I would also join Elon Musk on the space rocket. I would do that as well. Then I would be bored. Then I would probably come back and substitute. And you think I tell you guys what you need to hear when I'm here being paid? Imagine if I had $50 million in the bank, was only a substitute. You'd really learn about yourself then. Of course. No, I wouldn't. But I would share a lot of it because if you can't live for the rest of your life on $5 million, I would end up donating the vast majority of that $45 million. The vast majority of it. Huh? Would I buy you a lifetime supply of gummy bears? Just some? Yeah, I could throw you a gummy bear or two. All right, so here we go. Couple of cases. Quadratic equation. So guys, I'm going to write out a linear equation. And this is from grade 10. 3x plus 2y minus 6 equals 0. That's a linear. This is a quadratic. What's the difference? That is going to say 0, but I didn't want it to say 0. I want it to say y. What's the difference between the two? There's an x squared term, yes? Okay? That is the definition of it. A quadratic equation has a max exponent value of 2 for the independent I don't even want to say independent for the variables. Maximum exponent value. Everybody cool with that? All right. So now I need to talk about the word equation. What is an equation? What do I need before I can call something an equation? I need an equal sign. So is this an equation? X squared minus 9 equals. Is that an equation? Yes or no? Sukbal says yes. Who agrees? Okay. X squared plus 9 equals what? A pi. Is that an equation? No, it isn't. What do I need? What's missing from what I wrote in black there before I can call it an equation? Yeah, it has to equal something, right? Now is it an equation? Yes. Everybody cool? So there's a slight slight differentiation there. This side, x squared minus 9, is an expression. Y is an expression. Expressions can only be simplified. Once I put an equal sign in there, then and only then does it become an equation, and then and only then can I solve it. Is everybody cool with that? In your factoring unit, were we solving or simplifying? Simplifying until when? Till the radical equations when we were solving. And what was the only difference? We would factor this, x squared plus 7x plus 12, and then we would solve it when we added the 0. Everybody cool? All right, let us talk, cabbages, about the easiest kind of solving. And that is this, the zero product property. All right? If I gave you this equation, A, B equals 0, what can you tell me about one of the values of A or B? One of them has to be 0, yes? Everyone agrees, yeah? If one of them is 0, that is a true equation, yes? So, this is true if A or B equals 0. Then that's true, yes? Right? Now let's change that to something a little more general. A is a term that I am multiplying, yes? Everyone agrees? What do we call a term that you multiply? A factor. So A is factor 1. Agreed? What's B? Factor 2. So if this is going to be true, factor 1 times factor 2 to equal 0, then factor 1 would have to equal 0, or factor 2 would have to equal 0. Does everyone agree there? Yes? And we already know this from the end of our radicals unit, right? Or the end of our polynomial unit. Because how did our polynomial unit end? We didn't have a single factor. We had something like x plus 7, and our second factor was x minus 4, yes? And then what did we do with that? That meant either x plus 7 had to equal 0, or x minus 4 had to equal 0. Then we did our algebra, right? And then we found our answers. What were our possible answers here? -7 or 4. Right? We all know that, yeah? Now, this was an easy one because all we had to do was switch the signs, yes? What happens if it is 2x plus 7 and 3x minus 4? Do the rules change? What? Do the rules change here? Is this factor 1? Does factor 1 have to be 0? So what would we do here? 2x plus 7 would have to equal what? 0. And what would we do here? 3x minus 4 would have to equal 0. And then we would do our algebra, yes? So what would be our answers here? What are the two things x could be? -7 halves or 4/3. Can everybody do solving by factoring? Everyone is Gouda? Great. Turn the page over and do that 4 times. I lie. I'm the worst kind of liar. 3 times. This is good practice because what's your test on tomorrow? Factoring. Oh, it's almost like I planned it. It's like I care how well you guys do. I haven't won the 50 million yet, so. So, those were 3 very easy ones. Everybody should already have them done, yeah? Now, I want to take a moment to do a couple of things. One, right here. In previous units and in grade 10, would we have left that like that? No, we would have moved the 3 up to the front, right? But in this unit, we're looking for this answer here, aren't we? And we know that if it's x minus 1, I'm just moving that 1 over, so I change the sign, yes? So here, I know if I just moved that over, I could change the sign. Is everybody cool with that? That's what I did there, yes? Everyone good? And then over here, I recognize that that's a perfect square and that's a perfect square, so it's just 2x plus 1 and 2x plus 1, so there's only one answer. Is everybody good with the easy ones? Everyone? Okay. Is there anything weird about A, B, C, D, E, and F on this page? Nothing weird about it, so you can do them, yeah? Right? Don't do them right now. Okay? You're going to do those in a minute. That's going to be your assignment when I shut up. Let's look at A, B, C, D, and F down here. Is there anything weird about those ones? Not really. Different letters, yes. But you will notice, what does every single one of them have that none of them in the first group have? They all have a leading coefficient, yes? So it's the slightly more difficult factoring, right? But we know how to do that, correct? I'm going to leave that too for now. Get to here. This is where I want you to be right now. What do you notice about this guy? Does he have all the same parts? But does it look like something I can factor? No. What do I got to do, Luke? Put everything on one side, right? So what would I do with this guy before I could factor him? What should move? Should I move 8, negative 5, 10x, or negative 2? There's one thing there, 2 things there that I wouldn't move. What are they? I would not move the 8. And here's why. You want your quadratic term. And remember, what makes it a quadratic is the squared. You want that positive. So knowing we want to leave that guy positive, is he already positive? So we're not going to move him. So he's staying on the left. So where does everything else have to move? To the left. And I'm going to get 8x squared. What happens to this 10? Negative 10x. What happens to that 2? Positive. So what do I have? Minus 3, and that equals 0. And then I would factor. Everybody good? Yeah? All right. Now, look at B. I'm going to stop there because you already know how to factor. Look at B. What would you do? What's ugly about B? Brackets. How do we get rid of brackets? Pardon me, Max? Or distribute. I didn't even get to finish your name. You already had the answer out. Whoo! You must have had a good Math 10 teacher. It was me, Yoon. It was me. So, Priyanka says we distribute. So what do I get here? X squared plus 10x equals 4x minus 8. Now, is my quadratic term positive? So he can stay there, yes? Where does everything else move? So I get x squared. What happens to that 4? So it becomes plus 6x. What happens to that 8? Becomes positive. And what does it all equal? 0. Everybody cool there? Because once I get to this phase, they are factorable, yes? Everyone is good? Great. Start. That's your work for today. It's the basis for the next unit, and it allows you to review for your last unit. You are doing up to and including page 73. Wait, not 73. Yes, 73. You do not do 74. 74 will be dealt with tomorrow or later today, depending on how well we do. Yeah. 72 and 73 is your job for today. Because you can't go on with this unit unless you have factoring like that fast. Okay? Now, due to the fact that you have a test tomorrow, I'm more than willing to use the last 10 minutes of the day to do a little bit more review if you guys would like that. Yeah? Okay. Somebody remind me. No, I'll set my watch. Yes. Sorry, Luke. Now, Joe, I don't need to set my clock, buddy. I can do something else. You've been talking to Yoon? That's pretty aggressive.
I'm aggressive.
I don't need this right now, Yoon. You know what's funny? I bet my super sensitive microphone recorded Navjot saying that. We'll have to check later. Can I put the first few answers for 72? Are people ready? My computer's frozen, so you got some time. Quality equipment, Yoon. That's key. Quality equipment. Everything okay over there? I shouldn't need to show anybody A through F. I should not need to go over those. You're testing on this tomorrow. That's the easiest kind of factoring. Please double check. If you're not done A through F in the first set there, just keep working. Go back and check it either later at this class or on the video. Adina. Yes, I will come and help right now. Sees this.
No, that's cute.
And there is the last 6. Oh, I didn't finish these ones. Yo.
Okay, so if you have like a can I
Right.
write one down?
Please do.
I don't even know if this works. I'm just doing this, but like if you were to move everything to this side, then you would square that, and it would go x minus 2, then square that.
Yeah, that would be an
You-
X,
would
though,
you-
of course.
Yeah, sorry.
Yeah.
Would you just go
Foil.
like this?
Yep. 2 minus X, and then foil.
Okay, yeah. Okay, that makes sense.
See you, John.